fellow scholars. Happy St. Patrick's Day. Our job today is to review what we know so far about statistics. So our learning target is I can use statistics to represent data, so to make a graph, present data visually, to analyze a data set, and then to compare data sets. So some things to know. A population is every single member of a category that you care to know something about. So the population of our class is all 36. If I wanted to study this population, our 36 students in the class, I would have to get data from every single one of you. If instead I wanted to use our class as a sample to make predictions about all high school students or all Reseda high school students, then our class is a sample of the bigger population. When we talk about statistics, ways to measure a data set, we've talked about two different kinds of measures so far. Measures of central tendency give us an idea about the middle of a data group. Those are mean, median, mode. They're all different ways to talk about the middle. So what's likely to happen if we added a new data member to this data set. And measures of variability or measures of spread. So far we've talked about range, which you guys knew before you met me, and we've talked about standard deviation and mean absolute deviation. We're going to add one more today called variance. So super fast, because I think you guys know this already. Mean, median, mode. Are you 100% certain that you can calculate mean, median, and mode? They're here. Notice, now that we're up here in precalculus level, and we've talked about sigma notation, you can think about the calculation to compute mean in terms of sigma notation. Right? So you add up all the data values and then divide by the number of data values. Measures of spread that we know about. You know about range. So I'm looking here. Oops. That's the range. We talked about standard deviation. The variance of a data set is like doing the same computation as for standard deviation, just not taking the square root at the end. So if you know a standard deviation and you square that result, the value you get is called the variance. So it's just worth bringing up here. We talked about it a tiny bit. Why are there two different ways to compute variance and standard deviation, depending on whether you're talking about a sample or a population? So if I'm going to, gather some information about our class, what's good? So the heights of the students in our class. If I wanted to know, I really could come around and ask every one of you about your height. If we did then some mathematics on your data for your height, then, and I was thinking of the class as complete, I'm not going to try to use it to make predictions about other teens or other people. If I was just going to use it to talk about the people in our class, then I've found data from the entire population. And there's no confusion about whether I missed any data because I got all 36 of you and I know your data. So you are a population. If I wanted to use that data to make predictions about other groups of people, and I thought that the data from our class was a good sample, even if it's a good sample, there's no bias or I haven't made bad assumptions about how we're related, our class is related to other groups of people, then just because I'm more likely to get data that is close to the mean, using our class's data to make predictions about other people, I'm very likely to underestimate the variance in the greater population. So that's why we divide by n-1 in a place where we're going to use that data as a sample to make predictions about other populations. If I've gathered all the data and I know exactly how many people and I get data from all those people, there's no underestimating to do because I actually have all the data from every person. If it's interesting to you, and now that you have some time, maybe at home, this might be a good time to Google somebody else's answer to that. If you're more interested about why we use n-1 to compute variance and standard deviation for a sample as opposed to a population. All right, so mostly today our job is to remember this process of computing standard deviation. You can kind of walk through example 2. It says quiz, oops, there we go. Quiz source for a class of 25 students. If you have 25 pieces of data for 25 students in a class, then you have information for the whole population. And when you divide to find variance or standard deviation, you're going to divide by that number 25. So I just want to clarify here, this problem, class of 25 students, we're going to use 25, well, we always use 25 for the mean, and then 25 to divide by here. Before you take the square root, if you add up all these differences squared, and then you divide by the number of students in the population, you get this. This number is the variance. When you take the square root of that, this result is the standard deviation. Now you're welcome to use your calculator to compute all these. You can see they didn't actually walk through and show that they calculated each of those square differences and then square the differences. You're welcome to use your calculators to make sure you know the difference between using population standard deviation and sample standard deviation. If instead we wanted to just take the last column of scores and say that that's a good predictor of what's really happening in the whole class. Now we're talking about a sample of the population. And when you go through to compute the variance and the standard deviation, you're going to divide by n minus 1. So you can kind of walk through that example here. So part of your classwork, let's see, there are 4 problems in your homework. Do I call it homework? Do I call it classwork? Whatever. Your assignment. So it's going to be practice computing measures of central tendency and practice using computing measures of variance, measures of variability, measures of spread. They all kind of mean the same thing. And again, you're welcome to use a calculator. You can use, I think shmoop.com has a good statistics calculator, but anything you find there, just make sure it has a way for you to indicate whether you want a population variance or a sample variance. Okay, so one more big idea so that you're ready to do the last problem in your assignment. So I'm here at the bottom of page P33. This is got a really big idea that's going to be even bigger for us coming up in the next couple of days. So this is a nice picture to help you understand, kind of like lay the groundwork for this idea. For certain kinds of data, which we'll learn to call normal data, but be careful because that word normal, it's one of those cases where mathematicians use a word that has a meaning in math and it's slightly different from what it means in like regular English. So for specific kinds of data set and data that comes up like a lot of the time, almost, we might even say most of the time, the data mostly falls within one standard deviation of the mean. So you can see here we have we said for the quiz scores in that last example, when we did the whole population, the mean was 7.4 and the standard deviation was 2.1. So if you go 2.1 up and 2.1 down, do you see how that's one standard deviation on either side of the mean? Most of the data fits within that range. So here, range meaning from 5.3 to 9.5. And if you went out from the middle 2 standard deviations, almost all of the data falls within those limits. So from 3.2 all the way up to 11.6. And knowing that is going to be what gives us the power to make predictions about these kind of data sets coming up in the next several sections. It's pretty powerful. We're going to talk about your SAT scores. So the last big skill I want us to be able to take away from today is to use measures of central tendency and measures of spread to compare two data sets. So I have two different groups of men who I'm observing for metabolic rates, according to this example. And the question is, can you compare these two data sets? And so specifically, which group has a greater variation in metabolic rates? So anytime you want to compare two data sets, here they just specifically asked about variation, but it would be expected that you would compute all those measures for both data sets so that you can make sure that you're making good comparisons. So feel free again to use your calculator. There's all kinds of online apps that you can use. You do not need to compute these statistics by hand. Although I want you to remember how to compute them by hand. So for each group, we're going to find mean, median, mode, range, variance, standard deviation. Okay. And then, let's see. If you took a look here, their means pretty close, right? So somebody, an amateur statistician, unlike you, but an amateur might say, oh, man, they're like pretty close. Maybe it's like the same kinds of guys in both groups. But if you look at the measures of variability, the measures of spread, you can see, look at the standard deviation here, almost twice as much. So it would be a very easy conclusion to say here that it's group one who has a greater variability in their data. Even though their means are the same, even though there's something about the middleness of the data that's the same, the people who we took data on, the data from the first group is very much wider spread. It has more variability, more spread. So you have a question, your homework, classwork, assignment. Your assignment is, remember we're in chapter 0, so all the pages start with P. I'll show you what it is because I have that page. So this last example, I made sure we did so that you could answer the last question in your assignment. Okay, so this is page P37. You're going to answer questions 1. I'll zoom in on this just in case you don't have easy access to your books. So question 1, mean, median, and mode. Question 5, to practice finding range, variance, and standard deviation. They specify here. These are pop. Question 9 and question number 11. Question 11 is the one where you're going to find measures of central tendency and of variability and compare the data to find which one has the greater variation. Good luck, and we'll see you tomorrow.